Okay, we have one more of the 6 basic trig functions to talk about how to graph it. And once again, we're going to be looking at this extra triangle representation here, where we see some right triangles involved here. So there's several right triangles involved here. The one we're going to be looking at now for cotangent utilizes the same triangle we use for cosecant. And we have this purplish, light purple is going to be the cotangent. So the way you can see that, again, as before, if our reference angle is down here, it's the angle between that ray, this one here, and the one going in the initial side here. Okay, that's the reference angle. Well, the angle up here at the top has the same measure as that reference angle. So if we're looking at the right triangle that has that angle in it, and then the radius here, the right angle's here at point P, then remember that if we do opposite over adjacent, we get tangent. So if we do adjacent over opposite, we get cotangent. So the adjacent side is this purple side. The opposite side is this radius, which has length 1. So the purple side over 1 is the cotangent. So the length of that purple side actually is the cotangent of that reference angle. And we just have to make sure we get the proper positive or negative sign in that. So we're going to take that and bring it across. And so, once again, as with all the trig functions here, when we rotate our angle from standard position, then the amount of rotation is the measure of that rotational angle. Of course, that amount of rotation is that arc length there on the unit circle. So that arc length, S, equals theta on the unit circle. Right at the moment it's 0.85 radians. Well, that means we have a corresponding x of 0.85 over here. So the two pink distances are the same. That's the same in all 6 trig functions. The input on the unit circle is an actual angle measurement, which is the same as an arc length on the unit circle, and the input on the right is an x value, which is a horizontal distance from the origin. In both cases, they're signed either a positive or negative sign. Now, so we want to take this purple distance and bring it over. So we're looking at this. So this purple distance here is the same as the purple distance there. So let's take a look and see what happens. Well, when we start at 0, it's actually undefined. Okay, but as we come in here, we're getting very, very large, so it's way up off screen now. And now it's starting to come down where we can see a length here and the same length here. And as this goes around the circle, that length is getting smaller and smaller, so it's going way, 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 way up high, positive, coming down towards, well, it works its all the way down to 0 when you get to right here at pi over 2. And then as we go here, that distance is getting longer again, but now in this quadrant, cotangent is negative, so it's the opposite of that length. And so this length here again is the same as that length, but it's pointing down in the negative direction. So cotangent starts at basically at infinity, works its way down, decreasing as we rotate around here, down to 0 by the time you get to pi over 2. And now we go into the negatives, working our way down. Let's see, when it's pi over 4 here, over here the cotangent is 1. And when you get to negative, or to 3 pi over 4, the cotangent is negative 1. And then we continue to go on down further into the negatives, working our way down towards negative infinity. When you get to pi, the cotangent is undefined, but then it starts back up positive again, and it repeats. Notice that whatever you grow in the first rotation, we repeat exactly the same in the second half circle rotation. So the first half circle rotation and the second half circle rotation are the same. You don't get any new values. So, what does this trace out? Well, it traces out a graph that looks like this. So here's the graph of the cotangent. Again, starts out towards negative infinity, comes down, hits 1 right there when you get to pi over 4, keeps going around, going down. We get to pi over 2, it gets to 0. Then we go further down, then we're in the second quadrant over here on the left. Then we're down negatives on here on the graph on the right. So we're going down from 0 down towards negative infinity. When you get to pi, it's undefined. So a vertical asymptote there. As we continue to go around, now we're back up in the positives, and we just repeat the same thing over and over and over again. And it repeats every half circle, so the period of this function is actually pi. Now let's see how that compares to tangent. We can see the tangent actually two different ways. We see it as this green distance here, which is the way we graphed it before, but that's the same as that distance right there. And of course that's the same as the distance here when we get up to the graph of tangent. Now let's look at the reciprocal relationship here. The tangent and the cotangent are going to be the same when they both are at 1 or both at negative 1. And so we'll see that's going to be, they cross each other on this line y equals 1 and y equals negative 1. And that's going to happen at, well, it happens when the terminal side is at pi over 4. That's going to be at, right there, at 1, pi over 4 comma 1. It also happens again when they're at 3 pi over 4, so that's going to be when they're at negative 1. And then we're just chasing the same thing again as we go around in this quadrant. So when you get to, say, negative 3 pi over 4, or at 5 pi over 4, which is where we're at right here on the right, they cross again at 1. And when we get over here at 7 pi over 4, or it would happen over here at negative pi over 4, or here at 7 pi over 4, we're at negative 1 again on both graphs right there. Okay? Now, notice that if you take any point here, remember there's a reciprocal relationship going on again. So there's the graph, there's the cotangent, and the green one right here is the tangent. They're reciprocals of each other. So the bigger one is, the smaller the other one is, and vice versa. So notice that the tangent is going to hit 0, okay, whenever the cotangent is undefined, and vice versa. So wherever the tangent is 0, the cotangent is going to have a vertical asymptote. When the tangent is 0, the cotangent is going to have a vertical asymptote. Notice that these are kind of mirror images of each other, but not not shifts of each other. Notice that since they're reciprocals, when one is getting larger, the other one's getting smaller. So notice that its tangent is always getting larger on one of its connected pieces. The cotangent's always getting smaller on one of its connected pieces. Okay, and there is cotangent. Now in our next video, we'll come back and we're going to talk some more. The next series of videos in the next next section, we're going to be talking about some of these graphs a little bit more, and about some of the properties that they have and some of the connections between these different ones in a little more detail as well, now that we have the graphs. So, big picture, once again, let's go back to the big picture. The big picture, before we quit, is that we have a graph on the left that's a unit circle, and by finding x, y, and r there, we can find all 6 trig functions, and we can actually visualize all 6 of them, either as a length within that triangle there, or in one of the triangles here, we can find those links. And so we can visualize those trig functions. And then we also have our Cartesian graph on the right, where we can visualize those as well. And so each one of these representations can tell us something about these trig functions. The one on the left, the unit circle representation, is actually how we define them, and in that case the input is actually an angle measurement, whereas on the right, on the Cartesian graph representation, the input's not actually an angle at all, it's an x value, but it's represented, it might still think of it as an angle, because it is an angle in the unit circle representation. And so we have 2 different graphs, 2 different representations, and each one tells us something about these trig functions, and each one may be useful in some ways.